Section: Introduction. In this section, we discuss how we evaluate text-to-image (T2I) models. While these models can generate high-quality images, they may not always accurately reflect the given prompts. Evaluating the alignment between the generated image and the prompt is a complex task that involves three main steps: creating a prompt set, designing human experiments to gather judgments, and developing metrics to measure image-text alignment. To create a comprehensive evaluation of T2I models, we emphasize the importance of selecting appropriate prompts that cover a wide range of skills. Previous approaches have grouped prompts from existing datasets into categories, but these datasets may not fully represent the diverse skills required for evaluation. To address this limitation, we introduce Gecko 2K, a benchmark with two subsets, Gecko R and Gecko S, that cover a variety of skills and subskills in a more detailed manner. Human judgment plays a crucial role in evaluating image-text alignment. By designing human experiments where raters assess alignment on a scale, we can gather valuable data. The design of these experiments, known as annotation templates, can impact the quality and granularity of the collected data. To ensure consistency, we conduct a study comparing 4 annotation templates and evaluate 4 T2I models on Gecko 2K. Furthermore, we explore auto-evaluation metrics for T2I models. By comparing existing metrics on a large dataset of human ratings, we introduce Gecko, a metric that outperforms others by addressing key issues such as question coverage and filtering out irrelevant questions generated by language models. Our main contributions include Gecko 2K, a comprehensive benchmark for evaluating T2I models, an analysis of the impact of annotation templates on model and metric comparisons, and the development of Gecko, a state-of-the-art auto-evaluation metric. Section Summary. In this section, we discuss the challenges in evaluating text-to-image (T2I) models, particularly in assessing the alignment between generated images and given prompts. We introduce Gecko 2K, a benchmark with two subsets, Gecko R and Gecko S, that address the limitations of existing datasets by providing a comprehensive set of prompts tagged with various skills. By conducting human experiments using different annotation templates, we compare T2I models and auto-eval metrics, leading to the development of Gecko, a state-of-the-art metric that improves alignment evaluation by considering word coverage, filtering hallucinated questions, and enhancing VQA scoring. Section: Related work. In this section, we discuss benchmarking alignment in T2I models. Many benchmarks have been proposed to assess various model capabilities within T2I alignment. Early benchmarks were small-scale and created to compare models directly. Later benchmarks, like TIFA, DSG-1K, and HIME, aim to evaluate a wide range of capabilities such as counting, spatial relationships, and robustness by using existing datasets like MSCOCO, localized narratives, and CountBench. Some datasets focus on specific challenges like compositionality, contrastive reasoning, text rendering, reasoning, or spatial reasoning. The Gecko 2K benchmark evaluates a set of skills by collecting prompts across subskills for each skill to create a discriminative prompt set. We also gather human annotations across multiple templates and prompts to estimate image-text alignment and model performance accurately. Automatic metrics for measuring T2I alignment have evolved over time. Initially, Frechet Inception Distance (FID) was used to compare image generation models, but it did not fully capture human perception of image quality or T2I alignment. Clip score became a widely used metric for T2I alignment, inspired by image captioning work. However, these metrics may not capture all aspects of image-text understanding. Metrics like VNLI, inspired by natural language processing, have been developed to evaluate T2I alignment using entailment. Visual question answering methods like TIFA, VQ2, and DSG provide interpretable explanations for their scores without requiring task-specific fine-tuning. In the Gecko 2K benchmark, we create a detailed skill-based benchmark to ensure good coverage. We introduce two new prompt sets, Gecko R, and Gecko S, to improve the distribution of skills and consider sub-skills. Gecko R extends the DSG-1K benchmark by resampling prompts for better coverage and removing length limits. However, it does not cover all skills or sub-skills. Gecko S is a curated dataset with sub-skills to address these limitations. We gather a large number of annotations per image across 4 templates to provide detailed information. Section Summary. In this section, we explore various benchmarks and automatic metrics for evaluating image-text alignment in T2I models. We discuss the importance of creating holistic benchmarks that cover a wide range of model capabilities, as well as the limitations of existing automatic metrics like FID and clip score in capturing finer-grained aspects of image-text understanding. Additionally, we introduce the Gecko 2K benchmark, which focuses on fine-grained skill-based evaluation and the importance of considering sub-skills to ensure comprehensive coverage and accurate assessment of model performance. Section Gecko S, a controlled and diagnostic prompt set. In this section, we aim to create prompts in a controlled way for skills that haven't been well covered before. We split skills into smaller sub-skills to vary the difficulty and content of prompts. Drawing inspiration from psychology literature and the limitations of current text-to-image models, we design these sub-skills. We start by explaining how we select and organize these prompts before delving into the final list of skills and sub-skills. To create a controlled set of prompts, we use a language model, LLM. We first determine the sub-skills we want to assess. For instance, for text rendering, we may want to test for generating English versus nonsensical words and the length of the text. We then set up a template that guides the generation based on these criteria. By defining a distribution over these properties, we can control the number of examples generated for each sub-skill. After running the LLM, we manually check that the prompts make sense, flow well, and align with the specified criteria, e.g., correct length and language. We focus on 12 skills grouped into 5 categories: named entities, text rendering, language, linguistic complexity, relational, action, spatial, scale, and attributes, color, count, surfaces, shape, style. We provide more insights into how we break down the skill of text rendering into sub-skills, following a similar approach for all categories. By employing this method and some manual selection, we achieve broader coverage across the sub-skills compared to other datasets. We ensure consistent results across different annotation templates. Section Summary. In this section, we aim to generate prompts in a controlled manner for skills that have not been well represented in previous work by dividing skills into sub-skills to vary the difficulty and content of prompts. We draw inspiration from psychology literature and known limitations of current text-to-image models to devise these sub-skills, curating a set of prompts using a language model, LLM, and focusing on 12 skills across 5 categories. By collecting human judgments using different annotation templates, we explore how the design of a template and background of annotators can impact the evaluation results of generative models, comparing 4 models and considering absolute and relative comparison templates. Section Comparing Annotation Templates. In this section, we evaluated the reliability of different annotation templates by measuring how much agreement there was between annotators. We used Krippendorff's alpha to assess this agreement, with values ranging from -1 to 1, where 1 means perfect agreement and 0 means agreement by chance. We found that most templates showed agreement above chance levels, except for one case. We also compared how different templates agreed or disagreed with each other using Spearman's rank and Pearson correlations. Based on the human ratings we collected, we determined reliable prompts where annotators mostly agreed. We then refined this set further by removing uncertain ratings. This process resulted in a total of reliable prompts for 2 different models. We found that using these reliable prompts increased the agreement between annotators when using different templates. Next, we compared the accuracy of different templates in predicting preferred models based on the annotations of the reliable prompts. We found that certain templates performed better in predicting these preferences for different models. Overall, we observed that one template was more accurate in predicting the results of these comparisons. We also compared different models using human ratings collected with the absolute comparison templates. By performing statistical tests, we determined which models performed better than others. We found that one model consistently outperformed the others based on human judgment. In summary, we found that the choice of annotation template can impact the evaluation of models, but some templates showed better agreement between annotators. Overall, one template stood out as the best choice for evaluating image-text alignment. Section Summary. In this section, we evaluate the reliability of different annotation templates by measuring inter-annotator agreement to understand how they impact data quality. We use Krippendorff's alpha to assess agreement levels, finding that most templates show agreement above chance levels, except for one pair. By comparing Spearman's rank and Pearson correlations between templates, we observe high overall correlation, with finer-grained templates demonstrating better agreement. Additionally, we identify reliable prompts based on inter-rater disagreement and find that using these prompts increases agreement levels across different templates, highlighting the importance of template choice in evaluating image-text alignment. Section: The Gecko metric. In this section, we will discuss the Gecko metric. We have found that using question answering, QA-based metrics has advantages over traditional methods like VNLI and CLIP. These metrics can pinpoint failures to specific questions, rather than giving a single, hard-to-understand score. They also benefit from the advancements in large language models, LLMs, and visual question answering, VQA, models. The Gecko metric enhances QA metrics by ensuring that the questions cover all parts of the prompt and by reducing incorrect information. A typical QA setup involves three main steps. First, generating QA pairs by prompting an LLM with a given text description. Second, using a VQA model to predict answers for the generated questions based on an image. And third, scoring the alignment accuracy of the VQA model. However, this approach has limitations. For instance, it can be challenging to control the number of QA pairs generated, especially from long sentences. Additionally, LLMs may produce incorrect information, leading to low-quality QA pairs. Moreover, the binary judgment used in scoring overlooks the uncertainty in predictions. To address these limitations, we propose a simpler and more effective method that consistently outperforms other benchmarks. We focus on improving question coverage over the text by splitting the QA generation into two steps. First, we prompt the LLM to identify key words in the text, and then we generate QA pairs for each of these words. This two-step process ensures a more thorough QA generation process, especially for complex text descriptions. To filter out incorrect QA pairs, we use a natural language inference (NLI) model to measure the factual consistency between the text and QA pairs. Only QA pairs with a high consistency score are retained. Additionally, we normalize the scores from the VQA model to account for uncertainty in predictions. In our experiments on auto-evaluation metrics, we compare different metrics and demonstrate that the Gecko metric consistently performs the best. We also validate the effectiveness of each component of our proposed method. Overall, our results show that the Gecko metric is as good as or better than other metrics in aligning with human judgments. Section Summary. In this section, we introduce the Gecko metric, which enhances question answering, QA, metrics by ensuring prompt coverage and reducing hallucinations. By splitting the QA generation process into two steps and employing natural language inference, NLI, filtering to remove hallucinated QA pairs, our method consistently outperforms existing metrics on various benchmarks. Additionally, we address the aggregation of scores from VQA models to better reflect uncertainty, demonstrating the effectiveness of our approach in aligning with human judgments and model ordering. Section: Correlation with human judgment. In this section, we evaluate all the automatic evaluation metrics on the Gecko 2K benchmarks by checking how they correlate with human ratings. We calculate Pearson and Spearman ranked correlations to see how well the metrics align with human judgment. The Gecko metric performs the best among CLIP, TIFA, DSG, and Gecko metrics, showing higher correlations with human annotation templates. CLIP variants, which focus on sentence-level alignment, perform worse compared to QA-based metrics. However, a stronger CLIP model like Pyramid CLIP can be a solid baseline for sentence-to-sentence accuracy. DSG ranks second overall, outperforming TIFA but falling behind Gecko. When compared to VNLI, which is fine-tuned for text-image alignment, Gecko still shows higher correlations with WL, Likert, and DSG. On the synthetic subset Gecko, S, the Gecko metric continues to have the highest correlation with human ratings. DSG ranks second, except for the SXS template where CLIP performs better. Different metrics excel in different skills. Gecko and VNLI are consistently good across skills. Gecko metric is better with complex language. DSG excels in compositional prompts, and VNLI performs well in text rendering. When focusing on reliable prompts in Gecko 2K rel, the Gecko metric outperforms other metrics across the board. Moving from Gecko 2K to Gecko 2K rel, QA-based metrics show increased correlations with human ratings, while CLIP variants show a drop. This indicates that QA-based metrics align more closely with human judgment. We also analyze the impact of three key improvements in the proposed Gecko metric: QA generation with coverage, linear normalization of predicted probabilities, and NLI filtering on QA. Each improvement shows a positive impact, with NLI filtering providing the most significant boost. Comparing the Gecko metric with other metrics on TIFA 160, Gecko metric shows the highest correlation with Likert scores, indicating its strength lies in the method itself rather than the models used. Section Summary. In this section, we evaluate various auto-eval metrics on the Gecko 2K benchmarks by correlating them with human ratings across different annotation templates. We use Pearson and Spearman correlations to compare the metrics, with the Gecko metric showing the highest correlation with human annotations. Additionally, we observe that QA-based metrics generally outperform contrastive metrics, and the proposed Gecko metric performs well across different subsets of the benchmarks, showcasing its robustness and effectiveness in aligning with human judgment. Section: Model Ordering Evaluation. In this section, we explore whether each evaluation metric can predict the ordering of two models based on human ratings. We compare T2I models using scores from absolute comparison templates and determine the majority relation as the ground truth. We then analyze how well each evaluation metric matches this ground truth in terms of significance and direction. We also assess how often the metrics align with the ground truth when models are ordered based on mean score values alone. Our findings, presented in Appendix, reveal that significant successful comparisons are fewer than comparisons based on mean values. Most metrics perform similarly under both criteria, except for DSG and CLIP. Notably, Gecko stands out as a metric that effectively captures model orderings based on human evaluations and shows strong correlation with human scores.